So yes, hello, I'm here to talk about the joy of small data. So my background is in data visualization. I'm sure we're all familiar with that term. Maybe you have some positive feelings, maybe some skeptical ones, but this is what I've been working in. And a couple years ago when we were all so excited about the possibility of data visualization and how we had this big data problem and we were going to visualize it and we were going to solve all our problems forever. And over the years, okay, I don't know, maybe some skepticism. So today I'm going to be talking a little bit about my kind of personal journey through working in data viz and some of the lessons that I've learned along the way. So I'd like to start with showing you the first project of mine that I ever did that I finished it, stepped back, and said, wow, that's data visualization. I've done it, it's wonderful. And I really, honest to God, felt like I had arrived in this scene. This was written in processing a while ago. If you care, this is visualizing math papers that cite 2 fields of math. So I was like, yeah, I'm gonna show all this stuff. And there was some very basic interaction. You could click on them to filter down. And but really it was just like this. I was like, oh yeah, look at all those thin lines. I just totally visualized that data. And to the point where when I was out, trying to get my first job is, kind of literally called myself data visualizer. I use that as my card and basically hey, I can make the data visualize. I can do those thin lines. Look at me, it's on my card, skepticism. So, okay, so first project at first job at a design firm called Stamen. This is for Airbnb. This is 2 markets in Airbnb where people live in one and travel to the other, and you see kind of these connections between different markets. And I'll be frank, this was made in about 4 hours. But it's one of those wow, it looks so visualization. And the sort of narrative flow on this was Airbnb is so cool, and look, New York is their biggest market. But really, the point of this is Airbnb is so cool. There was some other conference later in my life, and they're oh, do you have a photo of your work that you really care about? And I was like, oh yeah, and sent them over something that had worked on for months, if not years at that point, and they wrote back and they're oh, can we actually use this? Yeah, data viz. So contrast this is very first project that I did at that company with this one, and this is the project that got sort of the most traction and the most views and the most engagement out of anything else that I did at Stamen. This is for MTV. This is the most share-worthy video where they basically engaged the One Direction and Justin Bieber fandoms in a voting war with each other about which video was better. There were over 50 million tweets that people were doing just to get the little bars on this page to go over there. Now, from a data visualization perspective, this is a glorified bar chart. No one even cares about the little real-time line charty thing. No. People care if they're number 1 or number 2. And this is kind of this really humbling thing, because at one point, MTV is this is the website that's had the most traffic that we've ever had. This is so cool. And my data viz training is oh, but it's a bar chart. But this is something that people actually connected to. And so this was sort of what I was thinking about is how to build better projects. So these sort of thoughts that went into kind of my first sort of big independent project. This is Meshu that I started with Xia Huang. This is a sort of a generative jewelry company based on the places that you've been. So with Meshu, it basically is this map, and it has a search box, and you enter in places, and as you're entering them, it starts putting them on the map and coming up with this shape. And then that shape is either laser cut or 3D printed into jewelry. And Xia and I were both avid travelers, and we both worked in data viz. So for us, it was sort of natural to be kind of looking at your own life and say, oh, well, I have this data from traveling. Maybe I should visualize it. And then oh, I'd arrive at this thing that, is kind of meaningful to me. This is a trip that I took to Southeast Asia. These are the places that I went, and these are the first earrings that I 3D printed for Meshu. And so we sort of put it out into the world, we kind of launched it, and lots of people got really excited about it. And it was kind of funny because we put it out there, and like within a couple of days of launching, we said, oh wait, this actually makes no sense as a present like without a map. Because like you can give someone this and you're like, oh, it's this super meaningful necklace, like it's all the places we went on our honeymoon or something. But to them, they're like, well, it's just kind of a bunch of triangles. So we're like, okay, we gotta do this map. So we're like, okay, let's print postcards. And then we're like, well, if we're printing custom postcards, like we could print something on the back. Like, I don't know, maybe we should ask. So we emailed everyone. We're like, hey, do you want us to put anything on your postcard? And we thought, like maybe 1 or 2 people. But it turned out about 2/3 of the people wrote back. And we're like, yeah, like you should totally print this on the back. And like of that, about half those people like really wanted to talk to us about it. They're like, oh my God, like, this is my sister and she did this like trip around the world and it was really cool and now I'm giving her this thing. And like, they were really excited. And so it was so great to be able to connect with these people that were using your site because, usually I'd built projects where you just kind of launch it and you put it out there and kind of watch it, and like maybe your client is like, oh, it went really well, and people looked at it, and you're like, that's good. But like this, people are actually emailing me saying like, I want to talk to you about the thing you built. And I'm like, yes, so cool. And it's been really wonderful over the last couple of years of running that project. Just the stories that we have been talking to people, and people send in photos, and they sort of write to us about like what these pieces mean to them, kind of longer term. So while this was technically a data visualization project, there was data and we made a visual representation of it, I like to think of this actually more as data journaling. I like to think of it as kind of taking the sort of data points that we find meaningful, picking those out and creating something physical with them. Fun fact, Meshu initially launched, or I guess it technically still is capable, to connect with your Foursquare check-ins to make this data. And this sort of was this boon in the press of like, ugh, why would you want Foursquare jewelry? And rightfully so. Just if you were curious, here's what my Foursquare check-ins look like from a couple cities. We broke it out by city and by country, and so like me, having been on these actual trips, I can tell you what these mean. I'm like, oh yeah, that airport is the little point sticking out there, and then I hung out in the downtown area, and like, oh yeah, walking the strip in Vegas. Like, but maybe there's something about what you're capturing in these sorts of apps that isn't really what is most meaningful to you. And so that's really what I've been thinking about for the last little while, is kind of this difference between automated data collection, either automatic or semi-automatic, and memory. And by memory, I sort of mean the human process of interpreting data, the data of your life, and then how you kind of store that data as your memories. And there's sort of a fundamental divide in the differences between these two approaches to your life's data. So, the first one is this problem of insufficient data, right? If you have to be, using Foursquare to check in every time that something important happens, you might miss things because they're too important for you to be staring at your phone. Secondly, the other problem with this is this data cruft. This is my moves data. I used to live in San Francisco and be a freelancer, and so I didn't really have anywhere to go, and so I would just spend every single day walking around the Mission, kind of up and down from my house. And so all of these days kind of blend together, and while they were very nice days, do I really need to keep sort of the path data for every single one of these? And so what I'm trying to kind of get towards here is focusing more on the story that I want to remember. If you look at sort of your own perception of your life and the things that were important to you, it's really hard to be capturing those same moments as data. Now you might say, well, you're looking at too fine of a scale. Sure, day-to-day walking up and down the Mission, maybe not so interesting, but if you zoom out enough, hey, maybe that's compelling. So this is 4 months of location data. This is a trip that I took. And yeah, you know, like when you zoom out, you start seeing, okay, yeah, you know, yeah, I did go to those places. But you know, the data's a little noisy, and you know, there's still some pieces missing. Like sometimes when you're on a flight, you don't quite get it. So okay, so there's still something not quite right here. The next thing I tried was my TripIt information, because at least everywhere that I was going, I was, you know, sending it, you know, my airline stuff, my hotels, and so I, you know, kind of pulled out both flights and trains and hotels, and you know, encoded it like this, and you know, we're getting close there. This is sort of, you know, the difference between the sort of automatic collection, and then on the right is my TripIt information that I actually just went in and sort of backfilled with, you know, all the pieces that were missing from it. And, you know, me handwriting XML, probably not, you know, the best user experience. So in the end, this sort of turned into another kind of project like Meshu, which, you know, is sort of where you are the one who's entering in the places that are important to you, and you are sort of creating that journey yourself. Storytelling. So if we're back on the sort of trend forecast from data visualization, this was sort of what I think was the next big thing, right? You know, people said, okay, data viz, we're gonna visualize all the data, it's gonna be great, put it up on there, and then, you know, people are like, well, maybe that doesn't work. Maybe we need storytelling, maybe we need stories, we need to have this narration, you know, we guide people through what they want to, or what we want them to be seeing. And I think that there's, you know, a lot of value in storytelling, and, you know, certainly for things like passion projects, like marketing, like news stories, you know, you do have an actual message that you want people to be getting out of your product. But what do you do if the data is a bit more technical? It's a bit more pulled back, and what you're not trying to do is sort of communicate something, but you really just want to be opening that up for people to make their own decisions. So let me tell you about my day job. So I am working at the Jet Propulsion Laboratory in Pasadena, and I'm working on a mission operations telemetry analysis tool, which really is a fancy way of saying that spacecrafts make data, operators need to see that data and make decisions based on that data. So I am working with 4 missions currently, with SMAP, which is an Earth orbiter, Cassini, which is orbiting Saturn and its moons, Dawn, which is headed to Ceres and the asteroid belt, and the Curiosity rover on Mars. And so what we're doing is we're building this web application that lets people see the data, analyze it, figure out what is going on with their spacecraft, both in sort of situational awareness, spacecraft health, and in determining anomalies, kind of what went wrong and what do they need to change to make sure it doesn't go wrong in the future. And I realized at this point that it doesn't really make a lot of sense to talk about what I'm doing without sort of teaching you how spacecrafts work. So I hope you don't mind. I'm going to do a little telemetry 101 and teach you what these spacecrafts actually do. So there are 3 types of data that are coming down from spacecrafts. EHAs, EVRs, and data products. So EHAs are basically numbers. They're a stream of numbers. It's boop, 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 boop. And those are, you know, little numbers. So maybe that's like a temperature of the sensor, and you have temperature here, temperature here, temperature here. And, you know, they come in at different rates. Some are throttled at every 30 seconds, some are every second. But you basically get this, you know, continuous time series of numbers. Now this gets a little interesting when you can sort of overload the definitions of these, and you can have what's called enumerated channels. And so maybe if something is on or off, you would encode that as a 1 or a 0. So you have 0, 0, 0, 1, 1, 1, 0, 0. And then operators can go and look at that and say, oh, okay, at this point we're off, then we're on, then we're off. And so you can get those really complicated. You can get, I've seen probably up to about 50 different states that are being encoded as these streams of numbers. Okay, secondly, EVRs. So they're basically a print statement, it's a log, it's a statement, a string of words. And that statement is with a timestamp. So this is where a lot of the logging happens. So you would say, oh, the sequence is starting, sequence completed, or maybe, this temperature is running a little bit high, or oh, this temperature crossed a threshold that we predefined. So basically, those are all this logic statements that you set up, and then when it happens, it gets spit out as a print statement. And then the third one is this sort of cop-out of everything else called data products, and these might be higher resolution data streams like EHAs, or they might be something like a photograph from the rover. But we mostly don't deal with the data products. So we mostly deal with EHAs as numbers and EVRs as words. Okay, so got it? Are you ready to operate some spacecrafts? Yeah. It's easy. Like, I don't even know why people make the whole rocket scientist joke. It's like, got numbers and words, that's all it is. Okay, so we've set that up. I actually lied to you. Not all of them have all of those things. Cassini is old enough that they don't actually have event records. So they do all of their analysis on the channels. And so those enumerated channels I was telling you about, they use that, and they use the number streams. And so it's basically kind of looking at all those along the way. Cassini has a couple thousand channels, and so they have a very, Cassini launched in '97, so that is, this sort of older data model. Voyager, for reference, has under 100 channels, and most of them have not changed a value in 3 years, because Voyager is basically going forever, as long as it can, and just doing its thing. It's kind of nuts that we're still talking to Voyager actively and still figuring out, are you okay? So, Dawn. It has about the same number of channels as Cassini, a couple thousand, and Dawn has some EVRs. Dawn launched in '07. Dawn has under 100 EVRs a week. So at that point, got an average of 13 or 14 a day, and so you're like, okay, yeah, going along. Oh, look, something happened. We have a little log. Easy. Now, the newer missions, like SMAP, which launched earlier this year, SMAP has several tens of thousands of channels, and SMAP has over 30,000 EVRs a day. And that is insane. And so they have, basically when they're looking at this data, SMAP is also an Earth orbiter. So SMAP is basically sending back data all the time. These other ones have to schedule time on the Deep Space Network and say, okay, yeah, we're going to be listening for Cassini at this period of time. Cassini data comes in, then it goes to the operators. SMAP is like bam, 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 bam. And so, we'll see these screens where people just have, the EVRs on there, and there's just like, EVRs coming in like a couple every second, and people are just staring there like watching it scroll down. I'm like, how do you live? I mean, it's crazy. Curiosity rover has about the same data volume. Curiosity has 25,000 channels, about 30,000 DVRs a day. And Curiosity also has over 100 people that are working on it every single day. There's, I believe, 13 subsystems in the downlink. I don't know, it's over 10. And it's basically all these people that are trying to make sure that all their, little components are all working well. It's kind of crazy the amount of work that goes into this and kind of making sure that these, these spacecrafts are operating well. I think that the best analogy that I have for it, we like to think of these, especially, with a robot so delightful as this little Curiosity one, that we like to think that it has a personality and that it's off just kind of like exploring Mars and like telling us what's up. But really, it's this machine that we're sending commands up to, and it tries to carry out those commands, and then it sends back the data of like, hey, did I complete, what I was supposed to do today? If you're thinking about the types of analyses that people are doing, it's basically, these very intense, you have your model that you think should be acting, and every slight deviation from that, like you really want to investigate that. I had someone ask, okay, what's an example of like a cool anomaly? Like, what's like your day-to-day thing? And I was like, okay, so there was like a subsystem, like a little tiny part, and it was doing this thing, but it was a little bit hotter than it should have been, and it wasn't actually a big deal, but if it had continuing being a big deal or continuing happening with the same sequence that was firing, then it might have at some point been a big deal, but we figured it out, so it's not a big deal. Which, like, wow, that's really, and the person's like, okay. But like, can you imagine like how awful it would be if like every single day you're like, oh no, like a big part of this broke, Wow, this many, many, many millions spacecraft that's off in space that we can't ever get back and we can't fix, like, oops, something broke, like, better go tell Congress. No, you want it to be like, oh, I noticed this thing that was a slight anomaly. Now I fixed it. It'll never happen again. Like, hooray. Like Cassini hasn't had an anomaly in over a year. Do you know anything like, that complex that you're just like, oh yeah, it like continues orbiting a moon and sending back new information, and we're learning about, Saturn and its moons. Oh, no anomalies for over a year. No big deal. It's crazy. Okay, so back to what we're actually designing for it. So the big thing that people wanted to know was analysis at the speed of thought. So existing tools are really slow, they're clunky, people are like, okay, I know that something went wrong and I know I need to investigate it, and so I want to be pulling up, a graph of this channel that I think might be it, but that query can take a couple minutes, and so people are sitting there being like, is this really the thing? And if it's not, you're like, okay, I gotta get my other one, or like, oh, I see a blip, I need to zoom in, and you gotta wait longer. So we've been switching to, faster, basically we're switching to Elasticsearch, and it's really great, and it serves data up really fast, and so now it's like, oh, cool, we have this data, and it's really fast, and now we can see it. And so, like my friends in DataViz, they're like, oh man, what cool data viz are you doing for NASA? And I'm like, oh yeah, I'm doing line charts. But I mean, really, like, it's time series data, and people need to see trends, and you're like, okay, here's a boring line chart. And to them, they're like, what? Like, that showed up in a couple seconds, and I can click on a point and see its value? Like, whoa! So, it's really exciting, to be working directly with these people who are, like, so into using your software, and you're like, okay, yeah, it's pretty simple, but okay, it's really good for you, noted. And like, we blew their minds with a histogram, like we, the EVR data, we're like, okay, well maybe let's spin it and then show you like the count every, 10 minutes or so, depending on where you zoomed in, and people are like, what? I've never seen this before. Like, I've been working on my spacecraft for years, and like, I've never even thought to look at it like this. And, and we're like, okay, yeah, bar chart. So, wow, like how interesting, that these very simple representations can be so powerful to people who have never been able to see their data like that. So there's this phrase that gets tossed around a lot, that good design is invisible, that like by the time that something is so well designed that you've arrived at like the greatest design, that people aren't even gonna notice. Like, no one's gonna be like, wow, that was really great design. No, they're just gonna use it, Oh yeah, wasn't a problem. And I think that the corollary to this is that useful visualization is invisible, that like by the time that you get down to something that's actually useful for people, they're not gonna be sitting there like, wow, that was a really nice bar chart. They're just like, whoa, it's the counts of the thing. And you have to remember that space is made of people, right? Like, these aren't these sentient robots out there, that it's actually these people who have to be looking at this data and analyzing it and, coming up with insights every single day. So, to close, this whole big data thing, big data is for computers. Big data is for, a repository of information. Humans, like, we're not databases, Like, the way that we look at the world needs to be small enough that you can actually understand kind of what's going on. And so that's really what I'm focused on, and sort of, building these tools and these applications that allow people to connect with their data, to get such a small enough view that they can really hold it inside their head and actually understand what's going on. Thank you.